Hello, everyone. Welcome to the IEEE Communication Society podcast number 13. And today we have with us two distinguished speakers and experts from the 6G area. So I have Professor Berk Canberk with us. He's from Edinburgh Napier University, and he leads the research group on digital twin in Edinburgh, right? And then we have Professor Tommy Svensson. He's from Chalmers University of Technology in Sweden, and he also is a leading professor there in context-aided communications and several of the techniques in 6G and beyond. And we will discuss about these topics during our podcast anyways. So welcome, gentlemen, first of all.
Thank you.
Thanks for being here. So first of all, I want to start with something very basic, just to give the background to our podcast. So we recently have the IMT 2030 framework, right, adopted by the ITUR. So what it discusses is several key usage scenarios, right? So in 5G, we have had this triangular sort of framework, right? So now we moved with some more enhanced capabilities to that triangular framework. So now we have added integrated sensing and communications. We have integrated AI and communications, right? And then we have ubiquitous connectivity as well. So basically the objective of connecting the unconnected, right? So with all these additions, right? So of course, we are still working around our 5G advanced sort of base services, right, to deliver them in the next couple of years. But with all these additions, what do you think about 6G going forward? So what are your thoughts on the way things are going on with the 6G framework and in general applications, use cases, or anything that you would like to share? Berk, maybe?
Okay, yeah, I think with 6G, the most important part, at least from my side, is to bring this AI capabilities, like the smart capabilities, into the connectivity and the connections and the communication perspective. So being said that, previously, as you just said, Aryan, so we had this big data with us, like some years ago. But so we were collecting different types of data, the amount of data, and we were trying to deal with it. But right now, we are in a point with 6G, I mean, thanks to 6G, that we will have this smart connectivity and smart collection of data. So we will not need that amount of data, but we will need some kind of a selection.
Yeah.
And that selection should be some kind of an online manner, in a reproductive manner, or in an adaptive manner. So this huge capabilities brings us to another level, I think, and we are going to reach this thanks to 6G.
Right.
So AI is one of the big key aspects for us in this perspective.
Interesting. Thanks, Berk. Tommy, any thoughts from you?
Yes, I think with earlier generations, we added capabilities that were somehow good to have. But the digitalization in the society is getting deeper and deeper. We're getting a lot of dependability, and we have a lot of other challenges when it comes to sustainable societies. So I think it's on another level on commitment from the mobile industry now in the 6G era to be a very trustful player, to deliver connectivity services.
Yeah.
But then also we're adding capabilities on sensing services and embedded computing, automatic computing with MLAI techniques to not only to power the network itself, but also to aid, be a fabric for a lot of other applications.
Yes.
So
is it safe to say, Tommy, that 6G is not just about connectivity or not just about communications?
No,
it's beyond that.
The ambition from the mobile industry is to be a stable core player for the deep digitalization of societies.
Yeah.
And so I mean, with that it comes very high requirement on trustworthiness. And it comes very high requirements on sustainability capabilities. And that's twofold. Both that the network should be sustainable itself, but also to enable sustainable other sectors. So to deliver connectivity and inference capabilities for other systems. And then that you also mentioned, the inclusiveness.
Yes.
We need to get everyone on board.
Yeah.
Not even in the highly developed parts of the world, everyone are fully connected.
Yeah.
And then we have a lot of parts of the world where we need to step up.
Yes, actually, you mentioned about sensing. So I just remember that we also have to be careful about the sort of ethical concerns, security and privacy concerns as well. So basically, when you're about to monitor the environment or something, you won't be sensing everything, right? You don't require to be sensing, I don't know, some private network details or something like that. So do you think that going forward is not just the technical challenges we have? Is even beyond that, like societal concerns or some, sort of ecosystem concerns. What do you think about that?
Much, I think a lot, and not only me. We have, I guess you're aware, European research agenda is centered around EU projects. So now we have the 6G IA, SNS research programs with a lot of collaborative projects. And there are a flagship project is in the early phase of 6G. The HEX-X project started and finished summer last year, and January last year started the HEX-X 2 project that's continuing. Right. And there I think it's like almost 1/3 of the budget is devoted to sustainability. And so already in HEX-X we started a framework that we call key value indicators, KVIs. And
so it's not KPIs anymore, it become KVIs.
KPIs are there.
Right.
And the goal, at least from my perspective, is that the KVIs we identified, the key value indicators, they should be measurable. And for sure they will be measurable in the future when we have developed and deployed 6G and we can look back. Did we manage? The key challenge is how to measure our solutions at this phase in time.
Yes.
But that is at least what we were trying to work on. And so within the project, there are a lot of works on use cases, analyzing use cases and how they map to this framework. And not only within this project, then there are activities within the SNS. Also there are working groups to identify those and the other players here also, Wireless World Research Forum and then the whole ITU process to analyze how we can deliver on those values and also try to align and confirm the common values that should be behind the development.
I think it's quite interesting, actually. So that also kind of leads me to ask both of you about, let's say, the latest research that you are working on. So I know, Berk, that you are doing digital twin quite a lot. So you are one of the experts, at least from the UK. So, basically, it's a very fascinating idea that you can actually twin your physical world digitally, and then to sort of process like even minute details from your physical world. So what are your thoughts on these sort of technologies and the work that you're doing currently?
Yes, thank you, Aryan. Actually, as you said, we are working really hard like for the last 5-6 years about digital twinning.
Right.
And trying to underline specifically that the digital twin is not just a 3D monitoring, it's not just a real-time monitoring, it's something way beyond, way after that. So actually we are, in my group back in Edinburgh, we are focusing on this digital twin subject by scientifically dividing them into 3 topics, like a data part, we call it data layer. I have some PhD guys to work on this particular topic, trying to, as I said, this collect it in a smart manner, building all these different types of new data models in order to grab the data as soon as possible, grab in an intelligent manner. This is a huge research, huge scientific area. The second work we do in this digital twin umbrella is the modeling part. It should be in real time. And there should be some kind of a real-time communication between the data part and this modeling part. There the communication aspect comes into the scene. We also have another branch, again in the digital twin umbrella, which is like this online learning mechanisms, and try to be dynamic and adaptive, and giving feedback as soon as you have some kind of outcome, and then try to like adapt yourself accordingly, according to all these different types of data that you are gathering. So this digital twin is really a huge scientific topic for us that we are dividing into the data, virtualization, and this online forecasting, online estimation. I think there are lots of use cases. We are mainly focusing on the platform part.
Right.
So we are heavily working with one of the biggest company in Turkey in that sense, BTS Group, while giving this cloud access to the data. We have several companies and universities all over the world that we are working on.
Yeah.
This is the main topic I work on, like different aspects of digital twin networks and digital twinning.
Right. So, I mean, it's quite interesting, actually. So, do you think it has even like more use cases or applications? So, for example, I can think about, let's say, public safety scenarios in disaster management. So, you might be able to, I don't know, find some sort of model, replicate that disaster-affected area digitally to figure out that, how we can rescue people, how we can search, or what do you think about that?
Actually, Aryan, we have a project going on with this topic.
Oh, right.
Yeah, so we are trying to monitor in a continuous manner the environment, and then when you feel that there can be there can be some kind of an anomalies in the future, in the near future, our platform can warn you about this, then in a real-time manner, using our particular real-time communication protocol, you can just reach to the base stations, to the sensors, not to the people, but to the device itself, as we called previously. You may remember both of you, this machine-to-machine communication that we had.
Yes.
So we were discussing a lot in 5G, but thanks to 6G and digital twin marriage, let's say, we can now make it alive. So we can reach to these guys, make them like an actuator instead of sensors, and then act accordingly. So digital twin really serve a lot in that sense as well for us.
Very nice, Berk. Thank you. So, Tommy, I mean, I also want to pose the same thing to you. So I know you are like an expert in several things. So you also work on digital twin, if I remember correctly, and context-aided communication, which is a very, very new topic. So what kind of research you have been working on within your group, and you're leading some initiatives?
I want to highlight where I come from into the digital twin. I come more from below, I would say. Because we started when we started work on millimeter wave communications. There you need to know a lot about the channel and propagation conditions to be able to do very reliable communications. So we saw great opportunities with a high system bandwidth for connected vehicles, particular, so cellular V2X. But the challenge is then to reach the users due to the dynamics. Cars are moving, there are blockers coming, and so on. So to harness the capabilities on the wide system bandwidth at the millimeter wave carriers is a challenge. So whatever information I can get to guide my communications is the key here, because we cannot measure everything by beam scanning and probing and sending a lot of pilots. We are drowning the system by these sensing signals and the reporting. So what can we do? Well, one thing is that we can try to learn from before, very from beforehand. If we go or drive around in the city, there are a lot of stable reflectors and stable blockers, houses and things. So those we can know from beforehand. And that is a stable context. And then on top of that, we can measure and track dynamic objects and bring them in to a system that knows this. And we use that prior knowledge to guide how we are communicating. And the more we know about the importance of the communication as well, the more we can decide when and how to communicate. And there comes the context. Can be detailed information about the upper layers, what I need, and all the KPIs for the communications. But can also be situation awareness. Can we really trust this information we have at hand now? What is going on around these things? Are there risks? Should we be more robust?
Yeah.
Then I come from another direction, and that is from the trustworthiness ambitions of 6G. That we want to support the deep digitalization with the help of the 6G infrastructure. So for me, that means that digital communication in general and mobile communications in particular is not only a good to have thing anymore. It's not only an aftermath thinking for a city design. That it's as vital as the power, as the water supply, as the transport, the roads. These are the digital roads. They need to work. So can we also use a digital twin to, at the early phase, tell the city planners with a strong visualization tools?
Very nice.
Show them how are the communication capabilities, what are the potential service capabilities, how the city looks today. Can we improve the current buildings, for example, with reflecting intelligent surfaces on buildings to help the multipath connectivity in the environment? And then even more important, when you're making new buildings, can we look into different designs options also from the perspective of the wireless communication and sensing capabilities at the design, architecture, planning, city planning phase?
Yes.
So actually we are doing that at Chalmers now. We have an internal project where we work with the civil engineering department and the Digital Twin City Center at Chalmers. They have worked a lot on wind simulations, noise simulations on. Now we're adding electromagnetic simulation capabilities in the smart city digital twin platform. And we will go all the ways to visualization on this.
Yes, so I think this is very interesting, actually, Tommy, that you mentioned. So we are thinking like different use cases and applications in totality. I mean, you come from, I don't know, making urban city, or maybe some sort of smart healthcare, smart factory solutions, or something, I don't know, as we were discussing about public safety as well. So you are touching each and every point. So it's not just about, let's say, a couple of applications. So it looks like that considering several challenges, of course, we have trustworthiness that we need to be really careful about, inclusivity as well, and also security, privacy with the sensing capabilities we are talking about, and also about the case of disaster management scenarios and many scenarios that we already discussed. So the idea is that we want to touch with 6G infrastructure several of other aspects as well. So it's not just sort of providing connectivity to people through mobile phones and stuff like that. So it's not just that anymore. So 6G infrastructure is able to touch many aspects. I know it looks very promising and very ambitious, but do you guys think that this is sustainable, for longer term? Or do you think that these things we're talking about are very just immediate and they just die up with 6G? That's it. Let's say in 2032 we have 6G infrastructure. We will not have everything, of course. Many of these things may not make it, maybe transferable to like maybe 7G or even beyond, right? But do you guys think that with all this ambitious plan, do you think it is very feasible to go forward with what we are talking about with all these aspects, or do you think that it's not just very long term? It's just a couple of things touching only for 6G. What are your thoughts? I mean, I'm quite intrigued by this.
Yeah, I think we will go beyond that, Aryan. I mean, whenever we will be done by like having this infrastructure, you were mentioning about it. I think, for example, I mean, if I can a bit answer it or comment it in a digital twin way, let's say.
Yeah.
So we will have this like hologram communication coming up, hologram computing coming up with the quantum as well. And we will have all those different types of data gathering from different types. And this will bring us to a complete new era. I mean, of course, 6G will build us the complete infrastructure. And after that, I'm sure we will go beyond this in order to now try to get some feedback from people and then explore it further. So this is coming. This is with AI. I mean, this is already this has come to us in terms of the communication. But I think in any aspect, it will be in our life. It will continue to be in our life.
I mean, yesterday we were also having a panel, right? So we were having a workshop yesterday. We were discussing all these points.
Yeah. AI for communication.
AI for communication. So what do you think? Because there are many problems as well with AI, with the complexity involved. I mean, we want to achieve the highest, the best performance possible. best accuracy possible, but at the cost of very high complexity,
and the heating, etc.
Yeah, exactly. So there are many problems going on as well. So what do you think about these points?
It's another good point we were discussing yesterday. I mean, this AI for communication for AI, of course, it brings some kind of complexity with us. This is not the way for us to stop. I mean, for example, as I said yesterday, I mean, in any outcome, at least the digital twin world will be a benefit of this, because we will need some kind of smart communication, or we will need AI to be connected thanks to this real-time aspect. So anyhow, I think even though we have some kind of complexity with us right now, with the physical layer technologies and scientific things that are going to come up, I think we will manage to merge AI and communication in a same pot at the end. So
it's difficult, Berk.
It's difficult.
We have to make it coherent. So Tommy, do you have any thoughts on that?
Yeah, I can comment on that too. If we really are serious about the word sustainability, go it literally, what does it mean?
Yeah.
Well, it means that what we are doing now should work for foreseeable future. And I think the best definition is when the sun is cooling down so much so we cannot live on this planet anymore.
Right.
That's basically what I think is the time scale for what we should aim for.
Yeah.
So it's not infinite, but it's very long. That also means that we cannot even store learning data forever, because sure, there are storage technologies that are close to zero energy consumption per bit, but even the final lifetime on the storage hardware.
Yeah, there's a limit.
So at one point we will need to read off and rewrite, and we need to have energy to produce that hardware and also recycle the old hardware.
Exactly.
So there's an energy footprint on any bit we store. It's not zero. It might be, we are working to make it low, but it's not zero. Sure, we have a finite lifetime, meaning that it doesn't really need to be zero. We can heat up the planet, and then when the sun goes down, we live on the heat on our own. And somehow, but at one point it will be approved. So we need to pick up the juice from the data and store it. So I think the next wave is to think more how is the brain working. The brain is very inefficient. And I'm not a brain scientist, so I don't know. But I can thinking about how my own brain works. I don't think I remember all details. I get the wisdom, I get the experience, I get some learning, I get some kind of automatic reactions on for different situations. And then I store a couple of examples that I can help to motivate my decisions.
Yeah.
So I think the key is learning and some kind of what's called lead-in, where you are storing the motivations and what's behind, so you can trace the model, where it comes from, what are the trustworthiness of the training data for it, what was the intention for the training, characterize it somehow, so we know how we can use it and under what conditions.
Yeah, interesting.
Here, I think there are a lot of work to be done, but we need to go that path, because the gold mining wasteful era is soon to be replaced.
Yes. When do you actually expect 6G to arrive? Let's say at least some initial sort of standards.
I think the 3D people will deliver on the basics first release of 6G by 2030. I mean, the standardization starts now. So that I think. Then the generations are very different. Since I've been around since 40 times, that was very easy. It was a mobile internet to the pocket.
Exactly.
With a main quality of service, IP core based.
Yeah.
Then that was mainly business to private consumers, also business consumers, but on the pocket. Whereas in 5D, we try to work with the vertical industries, more business to business, to create new revenue models for the operators and also help them, right? But even that took quite a long time. Even business to business, when we talk about industry automation, it's a closed company, factories. It's not out in the public, and it's a business to business. Still, it's quite a long time. Now we have ambitions to be a societal player in 6G. And in open public spaces with all the dynamics and also a lot of decision makers that are not engineers and are working on public money. So that's why I think the deployment of 6G will be very stretched out. And to make it happen faster, we need to work in the inverse there. This means that the use cases we are working on are not only to drive the technology development. The use cases are really a tool to discuss with different stakeholders what we can offer from our industry, what we can help with, and convince them that we actually can do a big difference. And this in particular then on the sustainability side with understanding the enabling effects of what we can do with communications, sensing, integrated sensing, and embedded computing and inference.
Yeah, so that's correct, actually, very nice. So you see that when you talk about like sensing and communication, right? So we already see that in standards, in 3GPP release 19, we already predefined some use cases for functionality requirements. So you have 32 use cases, right? So you have, let's say, dealing with AGVs or, for robotics applications. Smart healthcare is one of these, augmented human sense. Maybe try to provide centimeter level sort of accuracy for localization. Some positioning is there. So they're touching several aspects. Even public safety is one of the use cases there. So what they're trying to do is to address in a way that is feasible. So they are taking something very initial, like communication assisted sensing and sensing assisted communication, which seems feasible, right? And then you can sell to the stakeholders and the governmental guys that look, we are trying to, as you were saying exactly, is absolutely correct, is that we have these use cases oriented sort of technologies, and also we are working around something that is feasible, that is not just on the paper and looks too dreamy or something like that, that is actually achievable. So about the timeline, I'm not sure if they can catch it in 2030 right away with all the technology that we are talking about, because if you want to implement something in 2030, you need to freeze those standards in just next couple of years, so that people can actually work on these. It
should be layered, from physical layer up to the
and the application layer. So you need to, by 2030, if you want these things to happen, so you have to be quick into freezing your standards so that you can work around these technologies and get it in 2030. I expect maybe 2035, 2032, something.
Yeah, and then this
looks a bit more feasible.
Privacy, security issues are always with us, so they have to also, in the same time, deal with these things while improving the technology, which is the case.
Ethical concerns, many other things.
For example, in this smart healthcare application, let's say, I need to have your data, your body data. Will you allow me or not? This is a big question.
Yes.
Other than this, I can mimic it. That's fine. But then it's not be Aryan. It will be someone else.
And also, it's very important that look, how you're going to deal with this data. We see with many companies they use our social media data to provide us, advertisements and many things. So need to be very careful.
The data governance should be really like draw all the lines. And this has to be done while the technology also growing up. So it's a really way more than 2030.
There has to be some regulation to this when it comes to AI per se, and also with all these sensing capabilities and positioning, localization, tracking, for example. You require some compliance and some regulatory sort of considerations.
This explainable AI should be really in the scene, because you can convince AI. You can keep telling him that no, this is not right, this is not right, and then it will start saying to you the wrong thing. So you should be aware of this and then understand the algorithm behind it. It should be explainable. This is a way to go, but I think we are progressing. But we have some time to go.
Looks nice. So one more scenario I want to touch, Tommy, is about non-terrestrial networks, actually. So basically, this is a quite complex scenario, right? Even using AI, let's say, for resource allocation, edge computing we were mentioning, right? To edge cloud computing, let's say, they are putting out. So to provide direct connectivity from a satellite to your phone, let's say, or to any communication equipment that you're trying to use on ground, right? Because you want to work on the integration of ground network with the non-terrestrial sort of entities. It can be flying platforms, it can even satellite, and different layers of satellites, LEOs, MEOs, GEOs, and so on. So in such scenarios, if we add, let's say, AI, we add sensing to that as well. For example, in a disaster affected scenario, for example, so you want to, detect some, objects or some cars or whatever is stuck in that particular area. So you need to send the signal, which is actually having both capabilities, sensing and communication, right? You can connect with the base station on the ground, right, with some other control center unit far away that can take, that can monitor the situation. And also you need to send some, some objects and stuff. So this scenario, it does look very fascinating, but it's very complex.
Yes.
So do you guys think that in such a large scenario, when you have to cover large distances, let's say from 1,000 kilometers from the Earth's surface and on the ground, and you need to come down with your signaling, then you need to be sensing several things. And do you think it can be more streamlined and can be made less complex in some ways? We are working on cutting down the latencies and all that, but to add additional capabilities, like Tommy was saying, sensing and stuff, right? So can we make it a bit more simpler and not really complex? Can we make it more sustainable in a way that is also cost efficient and not costing us too much?
Yeah.
What do you guys think?
Well, I somehow think we should start on exploring all these opportunities for doing more than the connectivity. We actually quite I have a lot of hope for our big funding. We last Thursday we had a hearing for a youth research center application in Sweden on 6G SAT. So center called 6G SATnet for multi-purpose non-terrestrial 6G integrated networking. And so we focus on LEO satellites and multi-orbits, also collaboration with GEO and so on. And we will explore all these degrees of freedom here, particularly where, if you want to do computing, some kind of inference on the data, where should you do it? Should you do it on the ground, or should you do it already up on the satellites?
Exactly, yeah.
And one very important thing beyond the connectivity task objective of that center is to also look into opportunity for reusing the LEO satellites for Earth observations and aiding space science. And there are a lot of opportunities there because the satellites they have dedicated for Earth observation today are they get very low frequency on the information. So can we, using the data signals from the LEO satellites and use them as sensing signals and get the echo back from those to the LEO and then do Earth observations. This can be to monitor certain lands, flooding, wildfires, water levels on the oceans.
Yes.
There are huge opportunities here for multipurposeness. So I think we should start there, then to make this affordable. But one way is try to bring in more revenue chains to the system. I mean, either you make the system very cheap and based on mobile broadband or broadband customers' payment willingness to pay, or you try to get also the society needs into here and tap into the public funding for the bigger tasks.
Very interesting. So, but this needs some discussion actually around this idea, because it's very, very interesting to me as well around this thing. So Berk, I mean, have you got any thoughts around this?
Actually, so from this perspective, a bit like from the higher perspective, let's say in terms of the network and above application layer perspective, we need more some kind of scenario makers, which also brings us to the digital twin world as well. I mean, after like gathering this type of really precious data, instead of like I keep having them, we can just start making different types of scenarios and then say that, okay, this scenario works well with this type of satellite, this type of data. This is, we are okay with all the privacy concerns, etc. I mean, the dynamic behavior and this adaptive behavior of digital twin can also help us in this type of next generation communication, I believe. So
Right.
I think it's gonna be a case for us. It's gonna be complicated,
Yeah.
but I think we can manage to get up to that point.
I think it's interesting. I think it requires some sort of coordination between the industry stakeholders and the governmental organizations.
Exactly. We
Right.
have the triple helix here.
Yes.
And I think a very important convergence point here is on how to define and monitor the data. So there are works going on this on European level, and we are talking about that for some research programs now. Where we call data what do we call data spaces. So because if we can reuse the data for multi-purpose,
Right.
we save on communications and
Definitely.
on storage and on the AI processing on the data.
Yeah.
So I think that is very important to get a way to describe this.
Can there be some term like data reuse as well?
Yeah,
So,
I mean, if we can create
yeah.
the trust chains here, like maybe blockchain techniques or something to fully describe the origin, some kind of label on the data,
Yeah.
where it comes from, who provided it, what was the all the traces, all the footprints, and all the things we need for trust, and then anyone that want to improve these data sets,
Yeah.
continue measuring, there should be some kind of broker platform where people can tap in. Oh, I need the data too for this purpose. Okay,
Yes.
I need this quality. Okay, we didn't need that accuracy now, but you need. Okay, maybe we can measure more carefully, because then you can also use it.
Yeah.
Yes, that's correct. So also, I mean, this is a very interesting discussion in general. I mean, we are having. So, are you guys involved in any projects on EU level or in sort of national level that you would like to touch and share with our audience? Any projects that you have been leading and working around in consortiums that you want to mention? I know, Tommy, you're working with HexaX and HexaX2 projects as well. So, would you like to share any updates from your projects in general?
Well, I can highlight that the final deliverables are coming out soon there on the
Right.
HexaX2 project. So we are working hard to conclude those. And there are some testbed activities within the project, for example, on Isaac, that could be worth to have a look at. Then on national level, we actually have a quite big things going on now in Sweden for creating test beds and preparing on both on 5G, I mean evolving 5G test beds and creating 6G natural test beds,
Right.
which I think is very important then to create ecosystem at an early phase. At Chalmers we have also test beds on Massimaimo, on Isaac, on an advanced antenna labs, or also on terahertz level. So we are working on in different ways.
Very
for
nice.
creating
Yeah,
test
very
beds.
good to hear.
And then I mentioned this DTCC open digital twin platform that we are currently evolving, and I hope to collaborate more with.
Yeah.
Yeah.
Yes, we will. Yeah.
Guys, we need to collaborate three. So.
Yes, and with you. Yes, of course.
No, I'm kidding.
You are in between.
I'm kidding, yeah. So
Yeah.
anyway, Berk, I mean,
Yes.
how about yours?
Our digital twin as a service platform actually is being used a lot with several EU projects. So we have one country, one in the Open Run project. We have one with the infrastructure, smart cities going on. As I said at the beginning, we have 2-3 projects going on with Turkey, my home country,
Yeah.
with BTS and with Istanbul Technical University, different types of level project. We are doing this energy management in the UK now. In Scotland, we will have some transportation going on. One project with the energy level as well, and several things are going on at the same time. And
Good to
so
hear, yeah.
we are since we have this platform in an all technical manner, scientific manner in the cloud access. So I think we will have more and more collaboration together in the near future.
Very nice. So just before we conclude the podcast, I also want to ask you the very last question. So what do you think about, like in few sentences, about the future prospects of, whatever technologies we are working on, within our groups, or, whatever we are interested in?
Yeah.
What do you think about the future prospects of these technologies? You can even touch 8G, 9G, 10G if you like. So
yeah, I mean, from my perspective, things will go on as long as we keep the control as the scientists, as the AI. For example, AI is in the scene now.
Yeah.
We shouldn't let AI keep thinking instead of us.
Yeah.
So we are on
Shouldn't
top of
dictate
it.
us. Yeah.
Yes, yeah. This is one part that we all scientists should really be careful. Apart from that, I think we keep doing like the going on with the 6G, 7G. Whenever we are done with 6G, things are going on quite well in that sense. Of course, lots of complexities, lots of privacy issues are in the scene, but I think we will go on with this.
You will get by. Yeah, Tommy. Any future prospects you would like to mention?
Yes, I think from scientific point of view, the task on communications maybe will be more transformed towards a task of inference. Or for conclusions or actuation, for implementing actions in the physical world. And that would somehow be the starting point of problem formulations. And that will then drag in what kind of information do we have at hand for it at the point we need to make the inference or the actuation. And what do we don't have? Okay, that would trigger the need to measure. And we trigger the need to process that measure. And we need to estimate how much measurement do we need to do, and who should do it, and how much time does that take. And then we need to do the processing. Okay, where can we do that? How much does that take? How much communication does that involve? And at one point, we need to get all this basis for the inference or the actuation at the point of where that should happen. And that goes quite far away from bit error rate calculations or block error rate or so. So if we can somehow go in that direction also scientifically, I think that would be great. And another direction is really for me that we need to understand ML AI techniques. We need to get some kind of theories on top. In the worst case, we do it in a heuristic way, as what happened. My background is physics, so as to acknowledge what happens in physics for thermodynamics. There were measurements that were just hypotheses that summarize things in some equations that seem to explain the data, and they come up with the idea of entropy. And then later on, inspired by quantum mechanics, they postulated okay, maybe things are quantized, and you start to build on that and build a statistical physics. And then you could explain, and you could derive all these formulas. At one point we understood. So let's use ML to get ideas, and then we try to work with theories on top on it, and see how we actually should slice the cake in a new way to address larger problems in academic theoretical frameworks, and understand what we're doing. And avoid less and less of divide and conquer to address bigger problems.
Very interesting. That's the food for thought. So it's very nice that you touched. I mean, both of you touched on like different aspects of different things. So with this, I think we can conclude our sort of podcast. So thank you so much, Tommy and Berk, for being here, and it was really nice to chat with you. And hopefully, we three collaborate at some point.
Yes. We will.
And we do another podcast.
Exactly.
And we discuss about our research updates.
Yes.
And so on.
That would be fantastic.
Thank you so much, guys.
Thank you very much.
Thank you
very much.
Thank you.